Okay guys, let's do a little bit of modeling with trig functions here. If you recall in one of my previous videos, I talked a little bit about frequency. And I said, as the period length goes down, then the frequency goes up or vice versa. And that's because of this relationship here, which is that frequency, which is the cycles per unit of time, equals 1 over the period, okay? Because eventually you'll start trying to use these models in, say, an application modeling something, okay? So they give us a problem here in red, and they tell us that pressure, the maximum pressure produced from a pure tone is 2 millipascals. And you can always also look in the book here on page 506. And pressure equals A sine B of T. So that's just a general formula here that represents what's going on here. Okay, so they give us this information that pressure, the pressure from a pure tone is 2 millipascals, and they also give us that an audiometer produces a pure tone with a frequency of 2000 hertz, and that's cycles per second. And they also tell us that the max pressure is 2. So they give us essentially this information here, and then we're left to construct essentially a sine model that represents this. Okay, so first thing we want to do is use frequency to solve for maybe period, or B in this case. So frequency is 1 over the period. But remember, my period is defined as 2 pi over the absolute value of B, right? Okay, this portion here is my period. Okay, so if I want to find then the frequency, well, what would I do with this fraction in the bottom? You're right, invert it and multiply B over 2 pi. So frequency equals B over 2 pi, because 2 pi times 1 is 2 pi when we invert and multiply. Okay, and then they give us a frequency here of 2000 equals B over 2 pi. And now I can solve for B here, because I want to be able to construct a model, essentially write an equation that represents this situation. Okay, so then I'm just going to multiply here by 2 pi. And I will have then solved for what B represents, which is 4000 pi. Okay, so remember, frequency is 1 over the period, and then your period represents 2 pi over B, and then I flip and multiply, and I'm able to solve for B if, say, I'm given the frequency here in hertz, which are cycles per second, okay? 2000 cycles per second. Okay, so now once we solve for B, well, we've got one part of it. Well, then let's write our full equation here. P equals A, and A is, remember, the amplitude, which would represent essentially a maximum. So if they told me the max pressure was 2, and all of our other units are in millipascals, so I'm just going to leave it as 2. Then I'll have 2 as the maximum. That would be my amplitude. That's the most it can go up from the midline. Sine of B, and B we said was 4000 pi times T. And in this case, we're using T for time instead of, say, X, possibly for distance or time there. Okay, so once we write it, we can, of course, graph it. So let me erase. Okay, so again, so my amplitude is going to be the absolute value of 2, which is 2. My period is 2 pi over b, and b is 4,000 pi. Pi's cancel, 1 over 2,000. Okay. Okay, so if I were to graph that, let's put my period length over here, 1 over 2,000. And then I'm going to divide 1 over 2,000 in how many pieces? Divide it by 4. So I'm going to invert and multiply 1 over 8,000. That's how much I'm going to add each time. Let's divide in 4 equal sections. So 1 over 8,000. 1 over 8,000 plus 1 over 8,000 is 2 over 8,000, which is 1 over 4,000. And then 1 over 4,000 plus another 1 over 8,000 would be 3 over 8,000. And then finally we get to 4 over 8,000, which is 1 over 2,000. Okay. And then the maximum pressure it's going to reach is 2. And remember with sine, where do we start? Well, we start on our midline. Okay, so basically now we just modeled what's going on with the pressure in terms of, say, a pure tone here on page 506, and you can look at the example for more detail if you like. Okay, and why is my period length so short? Well, that's because its frequency is 2,000 cycles per second, right? So hence it's going to do one of these wavelengths in a very small amount of time, okay? And so we are able to then break it down. And remember, frequency is just 1 over the period, and if we need to substitute in for our period to solve for b, remember our period is 2 pi over b, and then we'll invert and multiply to solve for b. Okay, thank you. Okay, let's look at writing a more generalized trig function here and see the example 2 on page 507. Okay, so first we want to identify the vertical shift on something like this. This is obviously shifted, and we can do that by doing our max value plus our min value and dividing it by 2. So max it gets up to is 5 for y, plus the min is -1 over 2. Well, 5 plus the -1 is same as 5 minus 1, which is 4 over 2, 2. So I know k, or its vertical shift, is 2, up 2. And notice that's where our midline would be. It's shifted up 2, okay? And then notice this graph starts at the midline. So which one would I choose to model this sinusoid, sine or cosine? Well, if it starts at the midline, we're going to choose sine. Okay, so that's another thing we've identified. We're going to use sine. We know it's shifted up 2. And then let's find the amplitude and the period. Okay. Well, Let's start by finding b. Well, if I can't tell what a full period length is here, I can always say look at this location right here, pi8. Well, that's my period divided in 4 parts, isn't it? And that equals pi8. Well, let's solve for the period then. Because remember, whenever I took my full period length and divided it into 4 pieces, whatever I added to 0 was this amount here, right? So I know period divided in 4 pieces is pi8. Let's multiply by 4. So my period is 4 pi over 8, or pi halves. Okay. Well, period's good, but I then may need to use this information to, say, solve for b. Well, period, remember, equals 2 pi over b. We can always substitute in our period, pi halves, and solve for b. Multiply by b on both sides. And then what would we do with b times pi halves here? We'll invert and multiply, right? It's reciprocal on both sides, 2 over pi. The pi's cancel, and b equals 2 times 2, so b equals 4. Okay, so we're gathering up information so that we can, when we write y equals a sine b of x, we can fill in these values. Okay, so we've got b. Let's go ahead and solve for our amplitude as well. Well, how much does it rise from the midline or go down from the midline up to a maximum or down to a minimum here at max at 5, minimum at -1? Well, if our midline is 2, then it's going to go up 3 to 5, and it's going to go down 3 to -1. So our amplitude must be 3. Okay, so we're going to want to use information along the way to either find our period length, and then from our period solve for b. And then, of course, determine if it has a vertical shift. And hopefully we can then write one based on this. Okay, so let's go ahead and write it. Y equals, well, my amplitude is 3, sine, and we said b here is 4, sine of 4x. But it's also shifted up too. Don't forget that plus 2 out here. So midline shifted up 2. We've got a period of pi halves. 2 pi over 4 is pi halves. And we've got an amplitude of 3. So my equation to model this situation would be y equals 3 sine 4x plus 2. Okay, so this section is mostly for your kind of just exploring how you try and interpret these and work backwards to write some of these based on the information that they're giving you. Okay? All right, great. Thank you.